Table gives us some information about some carbon-based compounds. So we've got 4 compounds here, A, B, C and D. It tells us the number of carbon atoms, the boiling point, how they test with blue litmus, how they test with bromine water, their reaction with magnesium and their reaction with sodium carbonate. The question at the bottom says, use the observations to explain whether they're in the same or different homologous series, and use the data to identify and explain. I use the data to identify and explain which homologous series that the compounds belong to. Okay, so this is a question about homologous series. So molecules in the same homologous series have the same general formula. Okay, although the table here doesn't give us any information about general formulas, that's possibly not the most helpful one in the list. The rest will be good, I think. So they differ from neighbouring molecules by a CH2. They differ from neighbouring molecules by a CH2. By a CH2. Okay, so we've told the number of carbons here. And the number of carbons goes 2, 3, 4, 5. So it does go up 1 each time, so probably a hydrogen each time. So we should say that really, all these molecules, okay, have a different number of carbons. Now that doesn't guarantee that they are in the same homologous series. But if one of these had the same number of carbons, then it would be more likely that they would be different homologous series, because you can't have 2 different molecules in the same homologous series, essentially with the same number of carbons. Right, number 3, third on the list of what makes a homologous series a homologous series. They show a gradual variation. They show a gradual variation in physical properties. Okay, so physical properties are things like boiling point. So as the chain length gets longer, as the chain length, the number of carbons, as the number of carbons increases, boiling point increases. Okay, let's have a look into the table and just see that. So the shortest carbon chain is this one with 2 carbons, boiling point 118. Next one, this one, 3, 141, 4, 164, 5, 186. So the boiling point increases every time the number of carbons goes up. E.g., 2 carbons, so for example, 2 carbons, boiling point is 118, 3 carbons, it is 141, etc. Okay, next on what makes a homologous series a homologous series. 4, they have similar chemical properties. Okay, so none of these react with bromine water. If some of them decolorize the bromine water, then they'll be in a different homologous series. Right, space. Let's page to the next page. Has more space in your book. Right, all molecules turn litmus red. So that means they are all acids. So similar chemical properties, they are all acids. If you think this is stating the obvious, you need to state it to get the marks. If you don't state it, you won't get the marks. They're all acids. Okay, and likewise, our last 2, we've got reaction with magnesium. Magnesium is a metal. So all react with metals. All react with metals to make hydrogen, because the gas that gives this squeaky pop, in each case, is hydrogen. And they all react with metal carbonates, so sodium is a metal carbonates. They all react with metal carbonates to produce a gas that turns lime water milky. That's carbon dioxide. So they all react with metal carbonates to make a gas, to make carbon dioxide. Okay, so the homologous series, we think they're all the same. It's the same, and it looks to me like it might be carboxylic acids, because they are acids, and carboxylic acids don't have carbon-to-carbon double bonds, so they're not going to turn lime water colourless. And we could put an equation in here just to help us. So we said it was magnesium, so magnesium plus ethanoic acid is going to make magnesium ethanoate plus hydrogen. We could do that one for the reaction with magnesium, and we could do sodium carbonate reaction. Carbonate plus ethanoic acid is going to make sodium ethanoate plus carbon dioxide. That's the carbon dioxide plus water. Okay, so fairly straightforward 6-mark question. If you know your metals and acids, if you know your bromine water test, if you know your definition of homologous series. If you don't know those, then it would be terribly, terribly difficult. More of the story, learn your core knowledge. All these questions on elshamhighchemistry.com.